Welcome to the lesson on revisiting rational and irrational numbers. At the end of this lesson, you will be able to distinguish between rational and irrational numbers. You will also be able to prove theorems related to rational and irrational numbers. There is a big commotion at the Rational Numbers Club. The club is exclusively for rational numbers, but it appears some trespassers have gotten inside. It seems the rational numbers have identified the trespassers as irrational numbers, but the trespassers insist they too are rational numbers. This debate is really getting heated. Well, the law of Numberland has taken its course, and the accused trespassers have been summoned in court. The accused still insist they are rational numbers. Here is Mr. Public Prosecutor, who believes that the accused are irrational and not rational numbers. Let us see how he presents his case. Mr. Public Prosecutor is kind enough to present his notes on this screen for all of us to see. Mr. Public Prosecutor is starting by introducing the two parties to the case. A number is called rational if it can be written in the form P upon Q, where P and Q are integers and Q is not equal to 0. A number is called irrational if it cannot be written in the form of P upon Q, where P and Q are integers and Q is not equal to 0. The accused still stand by their claim of being rational numbers, but Mr. Public Prosecutor is all set to begin his argument. Let us hear what he has to say. The theorem Mr. Public Prosecutor wants to present states that if a prime number P divides Q square, then P also divides Q, where Q is a positive integer. To prove the theorem, let us assume that Q is a positive integer whose prime factors are P1, P2, P3 to Pn, not necessarily distinct. Thus, Q square is equal to the product of the squares of P1, P2, P3 to Pn. It is given that the prime number P divides Q square. By the fundamental theorem of arithmetic, Q square has a set of unique prime factors P1, P2, P3 to Pn. Thus, P is one of the prime factors of P1, P2, P3 to Pn. But P is also a factor of Q. Thus, we can say that if a prime number P divides Q square, then P also divides Q, where Q is a positive integer.